In this lecture, we shall do some problems on orbital motion of satellites, and my first problem will be involving the motion of Vostok 6, which carried women for the first time in space. So the first problem goes like this. It says that the Russian satellite Vostok 6, which was the first satellite to carry a woman into space, moved in an elliptical orbit round the Earth. The maximum and minimum heights of the satellite above the Earth's surface were 244 kilometers and 142 kilometers respectively. Calculate the mean radius and eccentricity of the orbit, its mean orbital speed, and its time period of revolution round the Earth. So first of all, let us draw a figure to understand the situation and the data given in the problem. This is a spherical Earth, and around it, Vostok 6 is orbiting in an elliptical path, which I am trying to show here in my figure. So you can see that this is the point when the satellite is nearest to the Earth. This point is known as perigee, and this is the point at the bottom when it is farthest from the Earth, and this position is referred to as apogee. You are aware of the terms perihelion and aphelion for the nearest and farthest point from the Sun. In this case, the corresponding words are perigee and apogee. So according to the question, the height of the satellite at this perigee position, this is the minimum possible, that is 142 kilometers. So I'm writing it here. This is H minimum. And correspondingly, at the apogee position, the height above the Earth's surface, this is the maximum height, that is H max. We'll also start writing down the data in the problem. They are telling us in the question that H max is given to be 244 kilometers, which is coming out to be 2.44 into 10 to the power 5 meters. And in the perigee position, the minimum height above the Earth's surface, that is given to be 142 kilometers, which is coming out to be 1.42 into 10 to the power 5 meter. And let us take this to be the radius of the Earth, expressed by the symbol RE. Therefore, if I could show some dimensions more in my figure, that this is the perigee position and this is the apogee position. I am drawing two horizontal lines through these two positions, as well as a line drawn through the center C of the Earth. You understand one thing, the center of Earth coincides with one focus of this elliptical orbit. That's important. There are two foci and one of them coincides with the Earth's center. So the minimum distance of the satellite from the Earth's center is, this is R minimum. This is given by, of course, the radius of the Earth, that is RE, plus H minimum. And similarly, the maximum distance of the satellite from the Earth's center, that is, I am calling it to be R max, which is equal to the radius of the Earth plus the maximum height above the ground. Is not it? And if I could show here, this is the length of the major axis of this elliptical orbit, apogee to perigee distance. This is equal to twice R, where R is standing for the length of semi-major axis of this elliptical orbit. So we find from here the minimum distance of the satellite from the Earth's center C, that is equal to the radius of Earth plus H minimum. This is coming out to be how much? We know the value of RE, that is 6.37 into 10 to the power 6 meter, and the value of H minimum is 1.42 into 10 to the power 5 meters. This is coming out to be 6.4 512. I am writing in 4 significant figures to avoid any rounding of error in the intermediate step, into 10 to the power 6 meter. Similarly, the maximum distance of the satellite from the Earth center at the apogee position is coming out to be the radius of Earth RE plus h max. This is coming out to be 6.37 into 10 to the power 6 meter plus the value of h max, that was 2.44 into 10 to the power 5 meter, and this is coming out to be 6.614 into 10 to the power 6 meter in 4 significant figures. Now once we have got the value of R max and R min, the corresponding apogee and perigee distances from the Earth center, you understand from this figure and elliptical properties that the length of the major axis, which is 2r, that is the sum of R max and R min. Therefore, the length of the semi-major axis, that is taken to be r, which is also referred to as the mean radius for this elliptical orbit, is given by the arithmetic mean of R max and R min, that is R max plus R min divided by 2. Putting the value, this is coming out to be R max is 6.614 into 10 to the power 6 meter, and R minimum is 6.512 into 10 to the power 6 meters. The average of that, and this is coming out to be 6.56 into 10 to the power 6 meters in 3 significant figures. We have got the mean radius, that is the length of semi-major axis of the elliptical orbit of Vostok 6. Now once we are here, this is the first part of the question, of part A of the question.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.